рисовать первая часть, зачем реквизировать? Минут 20 плюс. И раньше доклада, собственно. После чего можно будет задать вопрос.
Yes. And we'll try to do it in English, if you don't mind, okay? Thanks. It's going to be broadcasted on YouTube, Twitter. You can share it. The questions, they will be asked as well here, so somebody may ask something. We just started, you see there's already 11 people watching us. I have to do a little promotion before we start, and the promotion looks like this. So this is the code which you can use to buy a ticket with a discount for Java Day in November in Kyiv in Ukraine. It's a big conference. Who has been there at least once at this conference? Just 1, 2, 3, 4, 5, 6 people. Well, you have to go there. It's big. It's quite big. It's as big as JEE Conf, which just finished in Kyiv. So you can go there and you can attend it. So that's the promotion. So the discussion is going to be like 3 hours today, 2.5 or 2. No, less. It's 1 hour and a half. Yeah, 2 parts of 40 minutes. I'll be speaking about object-oriented programming plus Java together. And first, I'll start with a little bit of theory, just explaining what I mean by object-oriented programming, why it's good, why and how we can make it better. And then we'll go into practical examples in OpenJDK. So we'll just use that library to see how they break the rules and the principles, which I will try to show you in the beginning. It's going to be fun. I've never done this before, so don't blame me for being wrong sometimes. I'm expecting some discussions, so I'm not going to give you only the truth. It's going to be the discussion. So I just went through the OpenJDK, spent like a day looking at this library, at this code, and I found many places which I think could be improved. So we'll take a look at them together. First, I'll just give you a summary of what I think is wrong in object-oriented programming. Why I think Java, how I think Java is making mistakes in object-oriented. You're gonna watch this chat, I think, which is wrong. Okay, let me close this. So first of all, I think that object-oriented programming is needed because we want our code to be more readable and more maintainable. That's the whole point. So we want to decrease the complexity. That's the main problem in the modern code. It's too complex. Well, I can open like some, I don't know. The code which looks like this is really difficult to understand. It is complex, right? So we want to fight against the complexity. The code like this is difficult to maintain. We need to pay a lot of money to somebody really to read it, understand it. So that kind of code is wrong. Object-oriented programming is trying to solve that problem by decreasing the complexity and increasing maintainability, so-called. Maintainability is the ability to maintain something which somebody created. So maintainability of this procedure, this method, which is actually date.parse. So they're parsing the date. I understand it's not an easy task. You need to do like a lot of processing of the text. But if somebody asks me to refactor it, I'll probably charge a lot of money and I'll be not happy to do that job. So the complexity is high, maintainability is low. Object-oriented programming, I believe, was invented in order to solve that problem, to give us an ability to take part of the code and put it into some object, and then another object, and another object, and then hide the implementation from these objects and let us deal with the smaller problems at one time. Not with the whole big, huge, this procedure which is in front of me right now. It's a procedure, classical procedure, which you can see in C code, in old languages, in BASIC, and all that language. Java is not a good place for that code. So what makes, now I'll list you a few problems which actually makes our code still complex, even though we are in Java. So this is Java. Java was invented with the intention to make our programming object-oriented, but we ended up with this stuff. And this is not unique. I think you've seen that parts of that code which looks like that in your applications. So the first problem, I think, is that what makes our codes more complex and not helping us to solve the complexity is getters, so-called. You know getters and setters, definitely. So getters, they came to us, to Java, they were introduced in Java in order to solve, I don't know what they're introduced for, but they actually turn our objects back to data structures, which they were not supposed to be in the beginning. So they gave us objects, classes and then objects. In each object, they gave us attributes. And each attribute, they said, the attribute has to be private. It's a good practice to make attributes private. And then they said, but if they're private, you just introduce getters, and now you can get them out. So that is a wrong idea. So that's the first problem is getters. They make it possible for us to take everything out of an object and use this data outside. The moment the data jumps out of an object, the data becomes available, and then we end up with this. So first we encapsulate the data in the object. We say, now stay there. I'm not going to touch it. Let the object take care of the data. But then I introduce a getter, and through the getter, I take it out, and now I have to deal with the data here. So that's the violation of the idea of encapsulation. There's no more encapsulation. We started with encapsulation. We wanted to encapsulate, but it's not anymore. We don't encapsulate. We just let the data jump out. And we have the procedural code. That's the first problem. The second problem is static methods. So static methods, they are, again, not actually helping us to encapsulate anything. They're not helping us to break down the long procedure into pieces and put these pieces somewhere into objects and encapsulate that logic somewhere, and that nobody will touch that logic and that data. But static methods, they are just procedures without any objects at all. So there's no encapsulation at all. If with getters we violate encapsulation, but there is still encapsulation technically exists. With a static method, there is no encapsulation because there are no objects. So we just have a piece of code which, well, this is the static method. So there's no encapsulation at all. It's just a procedure which takes something in, some string, and returns the number back. So we're not touching any objects at all. It's just pure procedure C code, which we had long time ago. We don't encapsulate, we don't hide, there are no private attributes, there are no behavior, there's no state, there's no identity, no polymorphism, none of that. We just completely remove the entire set of object-oriented instruments, and we're just dealing directly with the C code. Even the label is here. This is like pure C code. Maybe the developer of that code, I believe it was, it was introduced it was deprecated as of JDK version 1.1. So it was introduced, I don't know how many years ago, maybe 20 years ago, when Java just started. So most likely, the person who did that was just a C developer. They just got that code somewhere maybe, or they just knew how to write that code, and they just created a procedure. They didn't know anything about objects. Okay, we need the object. Where do I place it? Okay, let me place it into date. Sure, let's put it there. It's just a namespace for them. This date is just a namespace for them. This is like terrible design in OpenJDK, in any JDK. So static method is bad. Problem number 3 is null. The null also came to us from old languages like C and others. You know what null is? Like, look at this code, for example, here. So it says if s equals to null, then break syntax. So I don't know what break syntax does actually. What's going to happen here? Break syntax. Probably it will, I don't know, I've never seen that before. So probably this break syntax will jump here. I don't know. Well, even it checks the input for null, and then if it's null, then it breaks syntax. So syntax here, and then it's what's going to happen. Yeah, and that will throw illegal argument exception, syntax error. I don't know why do you break first and then throw. Why can't you just throw? Anyway, it's everywhere here. Look, break syntax, break syntax. That's how they do it, huh? Okay. So null is wrong, and null can be used in 2 cases. First of all, it can be returned, and second, it can be accepted. In both cases, it's wrong. When we accept null, Well, in this case, we don't accept null. It just, in case of null, it's going to throw an exception. So it's more or less correct behavior. It's just validating the input and saying, if you give me the null, I'm not going to do anything for you, and I'm going to throw an exception. That is more or less okay. But some methods, some designs, sometimes accept null as a parameter. For example, what's the balance of the client now? And then you provide the client. And then instead of a client, you provide null. And if you provide null, it's going to give you the total balance of the bank, for example, or of the department. Some people design systems like that. So if the null is coming, it's one situation. If there is not null but real object, then it's a different situation. That's a wrong idea because the null came to us. Who understands what null is? I think most of you have to understand, right? Technically, what null is. Null came to us from languages like C. And it was literally number 0. So null is a pointer. It was a pointer originally, pointer to the piece of memory where the data were supposed to be found. So I'm expecting, for example, the name of the client, and you're giving me null. So in C, I'm expecting a pointer to the place of memory where I can find that client. So you're giving me some numbers, 9798, A, B, D, whatever, just long number. And then I'm taking that number, my CPU, the computer, the processor, it goes to that memory and finds the name of the client. That's okay. But if you give me null, meaning 0, 0, 0, so instead of a real pointer, you give me zeros, which is also a real pointer, more or less. Because there is a piece of memory which is the position of that piece of memory is 0. But I'm not supposed to go there. I don't want to do that because in that place in memory, most probably is the operating system or something like that. And then the computers sometimes they don't check for that and they go there, and then the segmentation fault happens. So segmentation you see sometimes it's exactly what happens when you don't check for null. If you try, maybe not check for null, but sometimes there is just wrong pointer, but the CPU is trying to go to some piece of memory and take something there, but there's violation. You're not allowed to touch that memory. So that's null. In object-oriented programming, we don't have pointers in Java. There are no pointers. We don't deal with pointers. We deal with objects. So null doesn't have any meaning, doesn't have any sense, because there's no memory. I'm not trying to access memory by accepting an object. I'm doing something else. So null doesn't have any, it shouldn't exist at all. And we should not return null as well. Returning null is also wrong, because when you return null, you are enforcing the client of yours, the library, which is the Java code, which is asking you for something, you're enforcing that client to check for what's coming out. Somebody asks you for, let's say, let's check this code. Let's say I'm so this is my code. So let's say I'm trying to find a resource in finds a resource with the specified name or the URL search path. So you probably know this method. Find resource or get resource or find resource. Maybe get resource is better for you. So get resources stream. Let's use get resources stream. Yeah, that's the description. So it says, so I'm asking my class loader to find something in class path. And if it's found, it's going to give me the stream, which I can use to read the data. If it's not found, it's going to give me null, if the resource couldn't be found. So that behavior is actually forcing me as a client, every time I'm calling the method getResourceStream, I cannot trust its result. I always have to check, did you actually return me something meaningful or it's null? Because if I touch that returned input stream, I'm going to get null pointer exception. So I always have to check it. I always have to check it. It's like extra problem on my shoulders. I'm using a library and I'm always expecting something happens like that. It's kind of betrayal. I mean, you're not giving me what I'm expecting. I'm expecting input stream, you're returning me null, which I cannot use. So accepting null and returning null is just a terrible practice in object-oriented programming. Another problem is setters and mutability. So setters, they allow us to, while getters, through getters we can take attributes out, through getters we can set something into our object. And by setting something there, we are immediately turning our objects into like small or big mechanisms which are just processing data instead of being objects that encapsulate data. Now we'll see the example later, but that's the idea. So the object has to be like that. You create an object and then it behaves for you. I mean, you're asking it to do something for you, you're giving some instructions, but you don't break what's inside. You don't touch what's inside anymore. It's just a solid black box which does some work for you. It just works for you. When you have setters, usually, in most cases, you create something, then you inject some data in there, then you say, run this data, process it somehow, and then I'm going to inject you something new. So you don't see the object as a solid structure. You see it like a collection of functions, like collection of procedures, which will process your data. That's all. They will just work on your data, not encapsulating them, but becoming just an open gate for what's coming, and then returning you some results. That's just conceptually wrong, because the size of an object will grow inevitably, and you will lose the idea of what an object is. So that single responsibility principle, quite famous, that will be violated immediately. Well, not immediately, but quite soon. If you have more and more setters. You will start with a few of them, and then you will introduce more and more. Most probably that's the class which has many of them. Let me check. No, not that one. Yeah, I think this one. So that's more or less, this HTTP cookie is a more or less classic example of that wrong design, because it has many attributes. There are many, many getters. You see, that's the getters, collection of them, and there's a collection of setters. So I can get whatever I want, I can set whatever I want, I can parse something, and I can print something. I can print this cookie to string. So it's just a machine which data come in and out, and it processes the data. But it's not HTTP cookie actually. So the name is wrong of this class. It should be called HTTP cookie processing machine, or HTTP cookie engine, or HTTP cookie set of utilities. But it's not actually one HTTP cookie, because at any single point of time, you don't know what kind of cookie it is. Because somebody already injected something there, somebody took something out. So it's just a collection of code which knows how to process certain data at a certain point of time. It's not really object-oriented programming. It's just we're using this HTTP cookie as a namespace where we just store data and store some functions. That's not what, for example, if you look at the class date, it is immutable. Even though it's not beautiful, it has this really weird code, but it doesn't have any setters. Look, they made them deprecated. Well, they have this set time. Okay, yeah, I'm wrong. So it's not immutable. Yeah, it is mutable. Even though the documentation says it's immutable. Let's take a look. I think date is immutable. Okay, maybe not date. Let's check at the file. That's the class we need. The file is immutable, and we have 0 setters here. No, it's not 0. Well, these guys are not really setters because they actually set something in the file system. So when you say set executable, it's not actually setting something inside the file, it just sends a request to the file system. So these guys are not really setters, they're just named wrong. So they're named, they look like they're setters, but actually they send requests to the file system. So they're not changing what's inside, they're not touching attributes. But the file is more or less solid structure, because when you look at it, you can say, yes, it's a file actually. So it's not a collection of something which knows how to work with HTTP cookie. It is a file which encapsulates path. I don't know why it's final, you see? So the attribute is final here. So it encapsulates the location of the file, and nobody can change that. Nobody can touch that file anymore. If you look at the HTTP cookie, then in most cases they're not private, they're not final. You see? All these attributes, they're not final at all. So they're changeable. This is wrong. This is bad. So having something really so mutable in your code for no reason, this is really wrong design. A few more things, and we will go into the code. Exceptions. Exceptions were introduced in not only object-oriented programming, in just the programming, as an instrument to solve the problem of error handling. So before exceptions in C, for example, that was really a huge problem what to do with errors, like what to do when something wrong happens. For example, you open a file in Unix, in C code, you say fopen, which is a function, and then fopen returns you the handler, to the handle of the file, which is just a number, 1, 2, 3, it's just the integer. So it returns you the integer when the file is open. And then you take that integer and you go to the function fprint, for example, and then you give that number to function fprint and say what you want to print into the file. It works okay, but what happens if the file is not open? If the file I cannot open, for example, there's no permissions or disk is full, whatever, then the fopen will return -1. So instead of actually returning you the number, instead of giving you the real number, it gives you -1. And when you will do something with this -1 and give this -1 to the function print, then you will have some unexpected result. I think it will not print. It will also give you some error code. So it's -1, and then you need to find out what really happened. So then you go to another function and say, give me the error code which just happened. So I just tried to open the file. So give me the code of the error which just happened. That was a mess because always it was necessary to check for this -1, check whether the file. So every time you ask any function to do something for you, you expect a normal result and not normal result. That was really difficult to write that code. They invent exceptions. Exceptions, you can throw an exception at any point of time in any piece of the program, no matter what happens. Now you just throw an exception and it starts to go up and up and up. So this code breaks, the exception goes up, and then that call to the function breaks, exception goes up. So it goes up and up and up to the highest level, and then the moment somebody actually catches an exception and do something with it. So you can throw an exception and you can catch an exception. Two things. And then people started to abuse that and use it the wrong way. They decided there are a number of methods how you can abuse this system. The first one is called flow control by exception. Flow control by exception, I'll show you the typical example of yeah, I've seen it somewhere here. Yeah, this is more or less what is called flow control by exception. So they're trying to do something here, and then they can't because there's some security problem. And because of the security problem, they decide that, okay, something went wrong, so I'll give something else as a return. And then, okay, the exception is here, which could mean anything. And we're going to give it something else. So they treat exceptional situations not as exceptional situations, not as really something wrong happened, but as like some indicator of, okay, you got trouble, I'll help you somehow. So they are controlling, I mean, maybe this is not a perfect example of exceptional flow control, we'll see more later, but the idea is that exception is exceptional situation. It's not just a flag for you that the code that now you should go a different direction. It is really exceptional situation. Something really is wrong. So you need to stop the execution of the software. You cannot just return something else, especially if this is an exception. Another problem what people are doing with exceptions is that they swallow them. Probably you've heard that called exception swallowing, meaning that I catch an exception and I just ignore it. Let me show you the example I've seen. Where was it? I tweeted about it today. Anyway, I'll follow here. Yeah, there you go. Look. So So this is called exception swallowing. So they just catch an exception and they say, yeah, it should happen. I mean, whatever. So if it happens, then we're going to return -1, even like pretending it never happened. So this is called exception swallowing. Needless to say that it's wrong. So we shouldn't do that. Why? Because we'll lose very important information which somebody, this guy, wanted to tell us. So they wanted to inform us that something is wrong. I don't know, socket exception, what could it be? Could be anything. Maybe, I don't know, the cable is disconnected. We lost the power. The whole network is down. We don't know what happened. And that's a signal. And we just ignore that signal. What happens if we do that? There are two approaches to the design of software. One is called failed fast. One is called fail safe. You know what it is, right? Who knows what fail fast is? Fail fast, one person. Two people. Okay, there are two approaches. You need to know that. There are two approaches to the design of software systems. First one is called fail safe. Two words, fail safe. Fail safe means what exactly this. So it means that no matter what happens, your code has to do whatever is possible to continue execution. Safe as possible. So don't break, don't stop, don't throw exceptions, don't show the user that something is wrong. Just keep going. Anyhow, the file is not ready, no problem, we'll find some temporary file. The socket is not connected, no problem, we'll get the data somewhere else. The internet is down, no problem, I'll show you the temporary page. I'll just do something just to keep you with me. This is called fail safe. Less safe for the user, so the user will see error pages not really often. In most cases, the user will survive, and the system will survive. This is called fail safe. Another approach is called fail fast. Fail fast. Fast meaning that no matter what happens, if I smell the problem, if I sense the problem, no matter what problem, I throw an exception immediately. So I just break. So the software tries to break as soon as possible. Throw an exception, show the page to the user, I don't know, report the problem to the log somehow, but break as soon as possible. So people say, and I agree, that fail fast actually makes software more stable. So if you make your software, if you design your software so that it breaks more often and in any possible case, then in general, the overall design will be more stable. Why? The logic is simple, quite simple, is that if your software breaks as soon as it can, then you will initially, when you start designing it, you will initially see more bugs coming from the software. You will see more exceptional situations, surfacing and showing to you their faces, and you will be able to fix them instead of hiding them and not knowing about them. Because fail-safe means that in this case, we will never know, ever, never, what actually happened there. We will put our code to production, it will work. Sometimes the user will call us and say, hey, I'm talking on the phone, and sometimes it beep, beep, beep. And I'm like, yeah, really, there's nothing in logs. Can be, everything is fine. But the user, no, really, sometimes, it was yesterday. I can't repeat it now, but it was, I swear. And we're like, no, logs are clean. Software is stable. You still can call? Yeah, I can call, but a little bit. We don't know why, because look at this. Because it said it shouldn't happen. Boom, we just swallow the exception. The user survived. If we design the software in a different way, and we just crash the phone call, then the user will say, you know what, I tried to call yesterday, and then in 2 minutes it just stopped. And then in the logs, we see the stack trace. Boom, the connection got lost, the socket got disconnected because this is that. So the user will be completely disappointed, but he or she will have a clear case explaining that, yes, I did a call and the connection got dropped. So I can prove it. It was not just a sudden beep, beep. It was like complete disconnect. In that case, we will fix that and all the users will be happy. There will be no blips anymore. Everybody will be more happy than just one user. So that's the mentality. So if you design all your code in that mentality, it will break, and you will fix. And then eventually you will have a more stable software because you will fix more problems which you will be able to see. If you do it that way, this is fail-safe. Like I said, yes, it will be okay for some time, but eventually your software will be like Adobe Photoshop. it's a huge pile of code, which people, that's what I've heard. I've never seen their code, but that's what people were, some people say, that if you look at the code of Adobe Photoshop and their systems, they're a huge monster, but it's so difficult to do something inside because it was designed in that approach. So they don't break, it always does something for you, but that's what I've heard. And there are many mistakes which you can find inside. So exceptions, there are two problems. First of all, swallowing. Second one is using exceptions for flow control. Because in this case, which we've seen before, it's going to be the same problem. It's going to be here. We're also going to lose the stack trace here. The exception happened here for some reason. We don't know why. And then we just ignore the stack trace. We ignore the real cause of the exception. We don't know why it happened. We just say, no problem, I'll give you 0, 0, 0, 0. So we kind of swallow in this case too. So we direct execution to a different direction, but we don't keep the information about what happened. So that's all over OpenJDK. I don't know why, but it's all over. I'll show you examples now. So this is one. I have one more for you. Yeah, and one more. The last one is, I believe this is my personal. Everything I've said before, many people will confirm. It's not just me saying. This one, I think, not so many people saying that. I believe that that constructors in objects must not have any code except, I'll show you now what I mean. Yeah. So the constructor is, this is the constructor. So so people say that there are two steps in the life cycle of an object. The first period is called instantiation, and no. There are two periods. The first one is when the object is created, instantiated, and the second period is when the object gets control. So first of all, you create a string, for example, and then you say, you create a date, and then you say toString. You create a file, and then you say .delete. So you say new file, then you encapsulate the name of the file, and then you say .delete. So there are two steps. The first step, you create an object. The second one, you say .delete. So you're giving control to an object. So I believe, and it's not just me, that these two steps, they have to be completely separate. So you shouldn't do anything while you're building an object. When you're just saying new file, you're not allowed to touch the file system. You're not allowed to work. You're not allowed to do something. You're not allowed to, like, look at this new socket, there's something, and then connect. So you're not allowed to connect in the constructor. When I'm building an object, I don't want you to connect anything. Just get ready for work. And then when I decide, I'll tell you connect, and then you will connect. So you shouldn't do anything while I'm still building, while I'm still creating, instantiating. I think it's really important because if we mix these two steps, some objects will do something during the construction phase, some will not do anything, then it's going to be a mess. And overall, the design becomes more messy and more complex if there's code in constructors. Because we start to think more procedurally, we think that the constructor is a good place to do something for us, and then we just treat constructors as function calls. So we're just saying, new socket, some address, and we expect it to be connected already, for example. I don't know what happens here, but I can assume that, yeah, something will actually happen. So there's going to be some connection. So I just created it, but then people will start thinking more and more about constructors as of function calls. That's what the theory is. Let me check, maybe there are some questions here. Oh, they're asking share my screen. Yeah, maybe they get tired of my face already. Hey guys, yeah, we have 15 people watching us, so unwatchable. Why it's unwatchable? Please come to Japan. Not now. Okay, why it's not watchable? Okay, we have a few more minutes before the break. So let me show some code from JDK to prove my points. Let me show the most funny parts. And then we'll have serious parts later. Yeah. This is really, oops. You don't do that. Yeah, let me share the screen. How do I do that? There you go. Yeah, oops. Yeah, you guys should see my screen. So it's yeah, I wanted to show something funny. Happened in code. Yeah, I like this one. Again, it's funny. I was actually thinking what it means. So what they wanted to say here, and then I realized that assert will only. Do you know what the difference between assert and throw? That's right. Yes, the assert will actually throw an exception. What's going to be the exception? Who knows? Assert error. That's right. So assert false will actually do this. It's going to be something like that, but it will only happen if you start your Java with this parameter -EA, I think, enable assert. So if you start Java just like that, for example, I don't know, main class, then this assert will do absolutely nothing, and it will just swallow an exception. So the execution will continue here. So you will try. There's some character encoding exception, something is wrong, and in production code, it will just continue and we will be here. Even though there is exception, even though there is a character, even though what's going to be BB in this case? Null. So what's going to happen in production? Null pointer exception. It will be like what? Inside JDK, null pointer exception because I don't have encoding? So you never understand that you have null pointer exception because you don't have encoding. You'll be just looking at this NPE and wonder what happened. Just because I don't know why they're doing this. This is my question. So what was the problem to say this? Illegal, I don't know. For example, why not that? It's a question for me. So for some reason they made assert. It's just funny. Maybe you can guess why it was made? I don't know. Another example. Yeah. This one. Let me show you. Yeah, this one. So they swallow, but they swallow something which is not a checked, which is a checked exception, but I don't think anyone here actually throws that exception. So what is this? What's the point of this code? So I can safely remove that. It doesn't allow me to remove, but I can safely remove this code and just have that. So what they're trying to do here, something really weird. So look, this is they're doing the calendar that equals to calendar. So this is just equals, just a simple function equals. So they're trying to compare two calendars. So then another calendar is coming in, right? And they're saying, okay, if this equals to object, okay, it's true. And then they're saying calendar that, they do typecasting, and then return compare to. So they're calling function compare to. It's somewhere here, right? And this one. Compare to, it does compare to of numbers, right? This one? It doesn't throw an exception. Look, there's nothing here.
Null pointer exception if you pass null.
Here it's going to be null?
Yeah, null pointer exception if null then expects if you.
No, but it's going to be null. Ah, okay. So null can jump in here. You mean that could be null? Yeah. Yes. Class cast. So well, this one. So here we can have an exception. Ah, okay. So if I pass something like string here, yeah. So the string will be here, and then return false, right? So yeah, I got it. So they just return false in all situations when this code doesn't execute as they want, right? Just no matter what happens, it's going to be false. If it's going to be memory, out of memory exception, it's going to be false. If it's going to be the system must go down, shut down immediately, it's going to be just false. So they completely ignore all possible problems which may happen here. They just ignore them and turn them into just one Boolean result. I believe it's wrong. What do you think? The main problem here is that they catch exception. Again, I don't have to say that, but I'll say that this is really a bad idea to catch just exception. You always have to catch the specific exception. The specific one. IO exception, Stack Overflow exception if you want to catch it, file not found exception, but you never catch just exception, because just exception means that you are catching all possible problems which may happen in the system at that particular time, including, for example, out-of-memory exception. Out-of-memory error. Error is going to be not exception. Okay, if you catch throw, some people catch even throw. So in that case, you can catch out of memory. Here, exception it could be anything. So when the exception, you're just catching all the possible situations, which is not a good idea. So you can do that only on the highest level of your application. Only when you're in the top level, when you really catch the problem and show it to the user. So that's the intro. On the second part, we'll discuss more practical design issues. Let's make a break. Okay? We're going to have food and questions you can ask. We can start the next part with questions, okay? And there must be food outside. Am I right? Yes? So that's it? Okay. Okay, we have pizza now, guys. I'm going to stop broadcasting. And I'll start it again in like 20 minutes.